Hello, I'm Gord Harling. I'm president of CMC Microsystems, and I'd like to give you a brief overview of our products and services. CMC Microsystems is a not-for-profit founded in 1984, and among other things, we manage one of the 16 MSIs in Canada, major science initiatives, called Canada's National Design Network. And what we try to do is provide infrastructure under a cost-sharing basis for our customers. We typically work in the domains of microelectronics, photonics, IoT, and edge AI, MEMS, nanofab, and integration, and as of 2 years ago, quantum computing. We are independent of the application. It really doesn't matter what drives you, whether it's advanced manufacturing, clean tech, agriculture, veterinary sciences, or health sciences. We just provide the tools for you to do your research. We publish success stories. These are just a few examples that show people who've used our tools as part of their research and have created new technology, often resulting in spin-off companies. We operate all across Canada, in every province, and every year we ask our subscribers to provide us with a survey of the outcomes that they've had. And as of 2020-21, there were in that year there were 4,000 publications, 150 awards, 80 patents, 14 new startups, and 610 people used our tools to complete their education or thesis work and go into industry. That doesn't count about another 800 that either continued their studies, went into institutions, went into academia, or left the country. And annually, we're connected to about 7,000 researchers and tool users. And in that year, we actually did 320 physical prototypes. We aggregated, we put them into commercial foundries and return the devices. This year, we're looking at doing very close to 400. So there's been excellent growth in the last few years. We operate a global supply chain. We have partners all over the world, both in CAD and in fabrication and in lab services. We also join many different communities. So if there's information that you require on specific markets or you want connections in other countries, we'd be very happy to help with that. And we do have peer organizations in other countries. We're all funded differently. We provide different kinds of support, and we have regular meetings with them 2 or 3 times a year to discuss best practices and delivery models for the infrastructure and so on. We again, our largest community is electrical and computer engineering, but for the first time, it's less than half of our members, or our subscribers, I should say. And we're picking up a lot of new interest in physics, mechanical engineering, engineering physics, chemistry, biology. And that to us is great news. We can expand the design network into other areas. And as you can see, ICT, communications technologies and information technologies is the lead, with biomed and pharma close behind. I'll be talking a bit about what we offer those groups. And the 5 areas that we support, you can see microelectronics still dominates, but photonics is in a very high growth mode. Typically, we would produce about 80, we would aggregate about 80 the photonics designs a year. And this year so far, we're already at 137. Our model is quite simple for subscribers to the Canadian National Design Network. Any faculty member pays $1,000. They supply the names of all the students, researchers, postdocs in their group, and they get access to all of our products. We have one limitation, and that is a single faculty member can only have 5 simultaneous users of the CAD tools. So if they have a very large research team, they can buy a booster pack of additional concurrent uses. But many universities asked us if we could offer a way of removing that limitation. And so if we can get a check from the VPR or from the dean, then we offer Research Plus for $5,000 for the entire institution. We'll remove that limitation. And that includes the education and classroom bundle, which allows about a dozen different CAD tools to be used for unlimited classes and unlimited students. So we have about 20 institutions have used the education classroom subscription, and about 10 or 12 buy the Research Plus every year. Our services are broken into CAD, Fab, and Lab. On the CAD side, we have about 30 different vendors of CAD tools. We purchase these and we put them into our private cloud. So you can access these with a browser, and you don't need to install them locally, maintain them, patch them, upgrade them. We do all of that for you. and we re-up them every year. So you have constant maintenance. It's all included in your $1,000 fee for your group. The beauty of these as well is that they are time shared, so that someone in one province can drop a license, someone in another can pick it up. And that allows us to serve many more users than we would with dedicated licenses per university. The vendors like this because A, they know that universities can't afford these tools, and so this gets them in the door and gets people trained in their tool. B, we provide them with market intelligence. When these are hosted in the cloud, they're actually available. We can actually see who used what tool for how long, and which tools are not being used, and that gives them an opportunity to know what they can do. When they supply these tools directly to the customers, often it's fire and forget, and they have no idea whether the customer is using the tool or not. So this avoids having a lot of tools used 1 or 2 or 10% of the time. Our tools are typically used 80 to 90% of the time, all day and night. We offer them on our cloud, and we would prefer that you use our cloud. It's much faster than downloading a simulation tool onto a small laptop and running days of simulation. And also it makes it easier for us to debug problems because we know we're working with a known operating system underneath the tool. And also this cloud has servers across the country, and they're in level 3 data centers, and they have automatic failover. So it's very robust, and your data is containerized and authenticated and extremely secure. We also have some hardware hanging off of the cloud. So there's a CAD compute cluster with 8.6 teraflops of throughput. You can submit batch jobs for COMSOL or ANSYS onto that, and you get a notification when the job is done. It has a graphical user interface, so it's quite easy to use. And we have an FPGA GPU CPU cluster. Here's one node specification. There are actually 8 nodes in that system. So you can do machine learning, you can try out hardware in the FPGA. You don't need a physical FPGA in your lab to use this. It's accessible for anyone in the country. And the middle box is actually an 8 petaflop AI inference and training system, which can handle 1,000 simultaneous users. We only have about 180 on that. It was just configured in the summer. So there's lots of capacity left there. And I've got another slide that talks to that. If you design something and you want to fabricate it, we work with a dozen different foundries around the world. These are commercial state-of-the-art foundries. One of our most successful partnerships has been with Global Foundries. So we offer their 45 photonics process, which is 45 nanometer microelectronics with photonics built on top of it. We also offer everything down to 12 nanometer FinFET design, and we actually have a course we co-developed with them on FinFET design. We had a poor year in 1920 when we had funding issues. Last year we did 320 designs, and as I say, this year so far we're almost at 400. So we expect that to continue to grow and to reach somewhere in the mid 400s next year. Mainly with microelectronics, but big growth in photonics prototypes, and still a very healthy MEMS prototyping activity. One thing that is perhaps underutilized is our awards for micro and nanotechnologies. So we want students to see other institutes, we want them to see other labs, we want to get them into bunny suits and into clean rooms. And so we offer 80% of the lab fees, the consumables, machine time, and if you're more than 50 kilometers away, we'll pay 80% of your travel expense. So do please submit your requirements to this, and it's basically continual uptake. You just submit a request, and we will cover 80% of your fees. It's only maybe of the 40 Canadian nanofabs, only 8 or 10 of them actually make good use of this. So please use it. In order to save time and money on equipment as well, we've purchased about 80 pieces of high value equipment, not wanting to have copies of gear sitting in labs underutilized. We ship this all over the country. So there's an online booking system. We prefer if you could book it for a month rather than 6. But if you can use these tools, we can ship them straight to you. The complete list is under the lab tab, and it's called equipment rental. But in fact, for subscribers, it's completely free. Even the shipping is paid. So if you have need of a piece of gear for a short time to do a measurement in order to get a paper out, do let us know, and we'll get this shipped out to you. We have a number of platform projects ongoing. One of them is the in partnership with Open Hardware. We're developing a 32-bit RISC-V processor with a 200K gate eFPGA on board. This is going into a 22 nanometer GF process, Global Foundries, and demo boards should be available by the fall of 22. The idea here is it's a very low power, high efficiency processor for IoT edge devices. You can play with it, you can try it out, you can write code for it, you can program machine offload engines into the FPGA. And if you think you can do better, then we have the entire design, including the demo board design, available on our GitHub, GitHub/CMC Microsystems. You can download the RTL code. You have access to all of the tools, the Gerber files, you name it. Everything is there so that you can go ahead and do your own project on this. And as we fund projects using MyTax students or Alliance grants, we publish the code that is generated. We've also been building hardware offload engines that are controlled by the RISC-V. And so both software and hardware will also be showing up on our GitHub as time goes on. There's one right now there for you, a barrel multiplier called Barvin. So do take a look and see if any of that is of interest to you. We also developed a small IoT platform. This little device here is about 1 inch on a side, and it has an accelerometer, a light sensor, and a temperature sensor. You shake it, it wakes up, it sends the peak acceleration, temperature, and light setting to an app on your phone or on a tablet via Bluetooth. So we've seen a number of applications for this. In one case, we modified the edge to suit a biomedical application where this is going on the back of a rat as a backpack, and some wires going into its brain will measure brain chemistry while we can determine its motion using the accelerometer and send all the data via Bluetooth. So the rat is untethered and the whole thing's battery operated. Other applications are popping up. So again, the entire design, the code for the processor, the code for the app on an Android device are all in the GitHub, and you can either get them from us, we'll ship them to you, or you can download and build your own and make modifications to it. 2 years ago, the first IBM Quantum Hub came to Canada, and CMC purchased a share in that. So we pay license fees to the Institut Quantique, to the University of Sherbrooke, and we have access to the largest IBM quantum machines, including the 127 qubit. So we've built our own coding group. We have a quantum group of 3 people in Sherbrooke, and we have to be the hands on the keyboard. This is IBM's stipulation. They don't want people exploring on the device, and so you provide your code to us in Qiskit or Python or C, and our people will make sure that it will run smoothly on the machines. And as long as we had a quantum coding team, we were interested in seeing what we could do with Xanadu. And so we ran a Xanadu quantum sandbox program last year. We expect to do another one this year. We've also purchased time on the IonQ machines, which are trapped ion systems. There's a talk right now of a system from Pascal using cold atoms to which will be brought to Canada. And also there's a discussion ongoing with Anion to build a superconducting machine in Montreal. So all of those will be available via CMC's development team. And right now we have a wide range of projects, about 17 projects on the go, and 6 papers already published in concert with academic groups, and a couple of industrial projects as well. We do like hardware, and so we've also launched a superconducting hardware course. It ran last summer with 24 students. They designed a 3-layer niobium into a 3-layer niobium process, and those are in fabrication right now. And so this is the tech platform development. So when CMC funds a project either by NSERC Alliance or MyTax, we apply an 80-20 rule, more or less facetiously, but we ask that the developers, since we're funding it, give us 80% of the solution as a platform that we can give to other people and host on our GitHub. And the 20% that's going to earn them a Nobel Prize, they can keep to themselves. So this is allowing us to demonstrate new platforms, and we're getting leverage out of these government programs at NSERC and MyTax. So it's been highly successful, and lots of new material is showing up on the GitHub. One example is an all-you-can-eat photonics device. This has 3 Mach Zener interferometers on it. It's got modulators, ring resonators. So a student can take this and put a laser on it and see what the function of a modulator or a Mach Zender is. If you're a small company, you might take 3 or 4 of them and wire up the components you need and demonstrate a minimum viable product to a funder. So we will have new versions of this coming out as time goes on, but there are 2 versions already, one in Advanced Micro Foundries AMF process and one in Global Foundries 9WG process. So do let us know if you'd like to see samples of those, and they will eventually be for sale on our website as packaged parts. We also have, thanks to Ted Sargent at U of T, an open phase transistor platform. You place a functional material on top which captures charges, and that modulates the channel of the transistor underneath. So originally, the functional material was a slurry, including quantum dots that absorbed infrared photons. And so in a very cheap, simple silicon process, you could make an infrared detector. But as time has gone on, we've been using MyTax to develop new recipes for a whole variety of different things. In fact, one of them is a COVID detector based on a graphene functional material. So if you'd like to see some samples of these, we have both on the top there on the right is a gases and radiation sensor. And on the bottom is a microfluidic sensor, for which we have a package developed at the Australian National Fab Facility. These are available, obviously, and if you'd like to design your own, then every year we have a fab run. Last year we put our own 2 designs on there, and also we had 3 other people camp on. It's very inexpensive to run, and you can do any sort of layout of sensors you like, and build your own system. We are also launching these silicon interposers. This is quite a unique process in that we take an 8-inch wafer, we put holes in it every 500 microns, and we fill them with a conductive material. And you can now flip chip or wire bond the die onto the top. You can put lasers, photonic devices, gallium nitride devices, whatever you like, and connect them together. So the beauty of it is, for one thing, it's 5-micron line in space, so pretty much any university lab can pattern that. And there are 2 layers of metallization on the top for crossovers, and 1 on the back, which can be used either for routing or for ball grid arrays, as you can see in the diagram. And at 5-micron line in space, this is about 15 to 20 times tighter than any printed circuit board. And because it's all silicon, it doesn't outgas, so it can go into a high vac system. And with some modifications, we're hoping that it'll be able to go down to cryo temps and still conduct adequately. So these are, right now we do have base wafers available, and we're working with the labs to get them to provide the routing patterning. In terms of AI, sort of a new area for us. We've built out our suite of tools here. So starting on the left, we can do AI training on the Atlas 800 cluster. 8 petaflop machine. We have the FPGA GPU CPU cluster, which is broken into 3 sections there, but with 8 nodes total. Once you've got a neural net model, you can use the DeepLight software, and we have their full commercial offering for our subscribers, so that this optimizes your neural net, makes it smaller and just as performant. And then finally, you can deploy it either on a box here, the Atlas 200, or using the 32-bit RISC core, which, as I say, will be in demo boards in the fall. Just to give you an idea of what we're doing at CMC, we have 5 technical groups with about 40 technical staff and over 20 PhDs. So the red projects are in planning, the yellow projects are in progress, and the green projects were deployed or launched in the last quarter. And this is constantly flowing, but we're constantly providing new platforms, new processes, new devices, and it's an exciting time. We also have a training format called Basecamp. In Basecamps, you get 2 to 3 weeks of intensive tutorials, lectures, workshops, and then you get 3 months of tool access in the cloud. So wherever you are, you can access the tools, and you do your own design. So we've been offering this via Lucas Krastowski and the SciEpic program for many years on SciEpic, the passive photonics and active photonics processes. Last year, we offered our first CMOS design for 12 nanometer FinFET. and that was so popular that we've had a second run of it this March. We also ran a superconducting circuits course, and we're developing courses for silicon interposers, the electronic sensor platform, and radio frequency design using GaN. So those should all be launched in this year. We have a variety of very prestigious awards, and there's a textbook competition coming up with an application deadline of April 29th. So do be sure to apply. There are cash prizes and a nice LinkedIn badge. Lots of events and training coming up, including the Earth to Space conference in June, Photonics North in May, and the Lab to Fab World Workshop in Whistler. So we'd love to see you there. We also want to connect to larger companies, and so we've created a program called Sponsorship, in which a company who's interested perhaps in 45 nanometer technology is looking at designing low power circuits or high speed circuits or voltage references or something. Then they can pay for the run, and we reach out to design groups around Canada, and we offer them free silicon if they are willing to design some circuits into this process. The IP is not transferred. The company does not get databases or layout or any of that stuff. What they get is a test report. And so they can look at the test reports, they can see what people achieved, they can see what their approach was, and they can decide to engage with those groups. So it allows them to kick the tires on 10 or 15 groups at once, and leverages our network, and really is the win-win for everyone. So we've had great success with that in the last few years. We continue to reach out to large companies to see if they're interested in stimulating the research environment. We also have a program for startups. So it's called VI, the Virtual Incubator Environment. And it is, we have 16 companies in there right now. It was only launched about 18 months ago. And what we said to our vendors was, yes, academics can't afford your expensive tools, but neither can startups. And they need them to get to a minimum viable product and a demonstrator and get funding. So with that, we were able to sign on quite a few vendors. And when we look back over the last 25 years, the university launched startups. CMC was accredited, shall we say, or thanked at least for starting 250 startups in the last 25 years. And the beauty of hardware is that once the customer has your part in their system, it's very, very sticky. They stay with you a long time. So 50% of these are still Canadian-controlled private corporations and active. Some of them sold, some of them perhaps went public, some of them folded, but 50% is a great success rate over 25 years. And the last 5 years, 95% of them are still active. So we're very proud of that, and we hope to see a lot more of that activity. And here's some details on the VI program. A dozen or so CAD vendors have signed on and give us more or less an academic style license, but for commercial use. We charge $2,000 per company. It's a bit of a filter just to make sure that you actually have some money. But it also pays for some of these fees. And the fab, of course, you have fab access using the cost sharing model that we use with everyone else. And finally, lab, we offer you some engineering support and access to some of the compute clusters that we have.